Hello, welcome to Chapter 11, Spatial Analyst, an extension for ArcGIS Desktop. So in this chapter we'll be working on several things, but as 11.1, which is the first tutorial, we'll be examining raster layers, and we will extract raster layers by a mask, and we'll learn how to create hillshade maps and a little more. So what we need to do as a first step is open the 11.1 map document, which is under your GIS T1 folder, maps. Scroll down to 11.1, and then you should see a bunch of layers: City of Pittsburgh, a land use layer for City of Pittsburgh, and you also see an NED layer, which is a shaded relief, which actually shows the elevation information, so which is also could be called DEM. So don't get confused, it's the same data. So the first step here is to actually look at the source tab for the DEM layer or the NED layer, and you can see the highest value has a value of 443, it has a low of 206, and you can also see that the number of columns and rows that are available, and the cell sizes, cell size for X and Y, and then the total data for this, the total file size for this layer. And if you scroll down, you'll see what spatial reference this data is in and the extent of the data. This is a slightly different format, or a very different format from the usual source information that we find on any other vector layers. Since this is a raster layer or a elevation layer, we find all this information about cell values and cell sizes and stuff. So that's that. Let's close this window. The next step is to actually set the raster environment. So how do you do that? Go to geoprocessing, click on geoprocessing options, and click on geoprocessing, click on environments, and here you scroll down to raster analysis. And here what you do is, instead of minimum of inputs, which means the cell size is automatically determined as a maximum of inputs, we'll say set it to a size of 50. So from now on, whatever rasters you create or extract, your size, the cell size, will be set to a default of 50. And then the mask. So the mask would be, since we are only interested in City of Pittsburgh layers, so we'll set the mask to City of Pittsburgh. So whatever data we create from now on, not for the existing data, from whatever data we create from now on, you will use this Pittsburgh layer as a boundary or a mask, which means anything outside this boundary will not be used in will not be displayed or will be cut off. Okay, click on OK, and now we need to extract this data for only the City of Pittsburgh. How do we do this? So I'm going to click on my search tab, and I'm going to look for extract by mask. So I'm gonna just type extract by mask spatial analyst tool. You might have to try a couple of different search words. And then the input raster is, let's extract the land use layer first. And now the mask layer obviously is going to be Pittsburgh. What we'll do now is output raster. We will save this into SRFS, GIS T1, my exercises chapter 11. In the GDB we'll save this as land use Pittsburgh. Click on OK and click allow it to run. It might take a little while depending on the speed of your machine. And now let's wait on this. Just one more. Let's turn the rest of the layers off except OHCA and land use Pittsburgh. So let's turn off DEM and land use. So as you can see, give a transparent or like a outline, just a dotted outline to city of Pittsburgh so that you can see inside the city of Pittsburgh. Click on zoom layer. So this looks extremely different from the land use layer that we already have. So this is how it's supposed to look like. So what we need to do is we need to import the symbology of the other land use layer or the source layer. So I'm going to click on symbology, I'm going to click on import, and I'm going to use my land use layer as my base or the source layer from which I want to import the symbology from. Click OK, and now I have imported the symbology of the source layer. Now I'm going to click OK, and it also gave me a nice description so that I can use them. So I'm going to turn off the other layer, the source layer. I'm going to turn on the land use layer. That looks pretty good to me. So the next step is to actually we'll work on applying a transparency and making it slightly better by adding a hill shade behind it. So that's 11.2. So let's continue working on 11.2 where we actually create a hill shade raster layer. So how do we do that? First, what we need to do is save this map as 11.2. You can save it in your exercise folder, which is obviously preferred so that you don't mess up the source layers. Save it as 11.2. Now what we need to do is let's go to our search toolbar. If you don't have it, don't worry, you can just access it by clicking Ctrl F or just clicking on this button right here. So type in Hillshade. So Hillshade Spatial Analyst. So the input raster here is going to be the NED PGH or DEM layer. So I'm going to use my DEM layer, and now I'm going to use I'm going to go with the defaults essentially. I'm going to save this to my Hillshade Pittsburgh. Give it a name and then go with the defaults. And click on environments. I want to check on something. I just want to make sure that the Pittsburgh layer is acting as a mask or not. So that's good. And now I'm going to click OK. And now that I have extracted the hill shade or created a hill shade for Pittsburgh, city of Pittsburgh. It sort of looks something like this. It's sort of a 3D looking image based on the elevation layer we just created. So what we need to do is go to properties of this hill shade of Pittsburgh, and now I'm going to classify. I'm going to click on classified for my symbology, and now I'm going to classify this data based on standard deviations of 1/3 for the best looking map. And now I'm going to click on apply. So that looks pretty good to me. So I'm going to go with that map. Just want to flip the colors and see what happens here. That's not what we want, so we want to flip back the colors. Click OK. And now what I want to do is move this map underneath the land use layer, because I want to see the land use, but I want to see it on top of my hillshade layer. But I want to sort of like give this land use map a sort of like a 3D look. How do I do that? I'm going to right click on land use layer, go to properties, go to display, and then in the transparency I'm going to apply a transparency of 35. So now, as you can see, this map has been given a nice 3D look of the hill shade layer that is below the land use layer. So that's how you take advantage of a hill shade layer to make your maps look cooler. So that's 11.2. So let's get started with 11.3, making a kernel density map. So in this example, what we're trying to do is create a map of heart attack rates outside the hospitals in United States between the ages of 35 and 74. So essentially we'll use a point feature class of census block centroids in the county to input an estimation method called kernel density smoothing method to analyze the heart attack incidence. So we'll learn how to do this based on two variables. One is cell size and one is search radius. So the first step is to actually open the map document from 11.3, scroll down and open 11.3, and now make environmental settings and get statistics. So that's the first step. So what you see is the OCHA, which is actually the recorded heart attacks, I believe, and we have the city of Pittsburgh layer, and we have the all county blocks where you have the data for heart attacks. Looks like female, the INC, I believe, is the heart attack rate, and then we have zoning and so on and so forth. So we'll get to that. So what we need to do is, since this is so hard to read, the INC data, you know, it's the same field. This is the rate of heart attacks. It's extremely difficult to read using this kind of like dot colors or hues of black to actually read this data. So even if we try with different colors, it won't be so pretty or so easily readable. What we need to do is go with an alternative method of displaying the same data, that is using kernel density. So the first step is to set your raster environments, raster analysis, and here you set your, as specified below, the cell size would be 50, again the same stuff, and we'll use Pittsburgh as our mask. Again, we are focusing on the city itself, so I'm going to click on OK. And now I'm really not worried about the data points outside the city of Pittsburgh. So if I run this analysis on the entire data set, it will take a lot more time. So what I'm going to do is select the data set that I actually want to analyze by selecting the location of all county blocks which are within the city of Pittsburgh, and click apply and see the selection once before we finalize it. Okay, that looks good. I'm going to click on OK here, and then I'm going to right click and export this data to user reference GST1. My exercise is chapter 11. I'm going to export this as actually, you don't need to export this. If you want to export it, that would be just fine, but what we are interested in is actually looking at the statistics of the selected feature set. So I'm going to right click on the INC field, click on statistics. So as you can see, the sum is 684. So the total number of heart attacks that are recorded within the city are 684. So what we do is remember that number. We'll come back and make sure that our data actually represents the same after we run the kernel density analysis. So I'm going to type in kernel density spatial analyst, and then the point layer is actually all county blocks, and the population field is INC, as we already know. And I'm going to export the raster into chapter 11 and call it kernel density 1500. So the reason I'm giving it a distance of 1500 is because I want to use a distance of the search radius is 1500. I'll explain why. So each block in the city is roughly 300 feet wide, and if we are going to add a defibrillator for public access, so it has to be within a distance of 2.5 blocks from the location so that they can it's easily accessible. So that's about a 5 block area, 2.5 by 2.5. So essentially that radius becomes 1500 feet on the side, so hence the 1500. So I'm going to go ahead and use that. I'm going to click OK and let the analysis run. So that looks great. So I'm going to turn off my all county blocks layer. So that looks like a much better representation of the data than before. So I'm going to right click on kernel density, go to properties. In the symbology tab, I'm going to click on classified method, and then I'm going to classify this data based on standard deviation. 1/3, and if you want, change the colors to greens to reds, reds being the most number of heart attacks. So I'm going to flip the colors. As you can see, this actually represents the intensity quite brilliantly than actually displaying just this data, which is actually showing the same type of data but not very efficiently. So that's the map we want to look at. So the next step is, so let's look at the mean, which is so let's move on. The next step is to create a kernel density surface with a search radius of 3000. I'm assuming you're gonna go ahead and do that. And the next is 11.4. Let's get started with 11.4. So we have the OHCA, which is the sort of called observed heart attack locations, observed locations of heart attacks, and then we have the kernel density, which actually shows the predicted or like estimated number of heart attacks. So what we need to do is we need to examine what is predicted or what is estimated using kernel density for these individual points of actual locations, and compare those two and say if population alone is a good predictor for heart attacks outside the hospitals. So the first step here is to search for extract values to points. Spatial analyst, click on that, and then the point features are the OHCA, and the input raster is actually kernel density 1500. And now we are going to export this as the OHCA predicted. So we'll compare the actual and predicted values and see if population based, the calculations that were based on population are good enough. And now we're going to say interpolate values at the point locations. So since this is a continuous surface, we'll interpolate the values based on point locations, and click OK here. So now we get I'm gonna turn off my OHCA layer. I'm gonna open my attribute layer, and we have a field called raster value within the OHCA predicted point layer. So what we need to do is create a new field, add a new field, and I'm going to call that predicted, and then I'm going to select float for the data type, click on OK, right click on this and click on field calculator, and I'm going to say raster value multiplied by 5. We are multiplying this by 5 because the OHCA data is a 5-year sample for heart attacks. So multiplying that by 5 would actually give us the right values. And now what we're going to do is create a scatter plot. Oh, actually I'm going to right click and click on select by attributes. So if you actually scroll down to the very end, we have values like -999 which are actually signifying missing values. So before we look at a scatter plot, these values would throw it off, or since these are outliers, so we need to select the only the ones that which are not, negative or missing values. So what we do is select by attributes, and we say predicted value greater than or equal to 0. Click on apply. So the values that are negative are eliminated. So once we have that, I'm gonna apply and close. I'm gonna right click data, export the data, and I'm going to save this as OHCA predicted GST1. My exercise is chapter 11 OHCA predicted 2. Save it and then add it to the map, and then what I'm going to do is I'm going to create a scatter plot of actual versus predicted heart attacks. So I'm going to click on view graphs, create a graph, and I'm going to create a scatter plot, and I'm going to make sure my values look exactly like the book. I'm going to click on yes field, which actually shows the actual heart attacks, and Y field is predicted. So we're comparing actual heart attacks to the predicted, and then left bottom add to legend, and then essentially that's it, more or less. Let's see, are we missing on something here? Predicted, add the legend. So as you can see, the scatter plot does not actually align around a 45-degree slope line. So all the dots should be around a 45-degree slope line if there was a correlation between predicted and actual. So we can conclusively say that there are factors other than population that affect the locations and clustering of heart attacks outside of hospitals. That's the conclusion from this analysis. Now click on next and click on finish. Close this map. And then how to actually conduct a raster based site suitability analysis. Let's focus on that. So let's get started with 11.5, conducting a raster based site suitability study. So the primary objective of the study is to actually find the suitable locations for having these heart defibrillators accessible to the public. So the approach being used is wherever there are high amounts, high number of heart attacks, in combination with whatever is the most favorable zone, like commercial zone, which is easily accessible to the public, a combination of those two or an overlay of those two would be the right fit for these facilities to be located. So what we need to do is to create and query these raster maps, and then use the Boolean operators such as AND or to combine raster maps to meet the required criteria. So let's get started. Open 11.5, save changes, no, and then so we already are seeing some data here. The blue ones are like a 600 foot buffer around the commercially zoned areas in city of Pittsburgh. So we already have access to so these are the most accessible locations within the city. We know that's sort of like an assumption that we use as part of this study. And then now let's set the raster environment, raster analysis, and then we'll use a mask of Pittsburgh, and then we'll use a cell size of 50 for this analysis as well. So we need to convert so if you go to the properties, as you can see, this is a file geodatabase feature class. It's a polygon feature class. It's not a raster. So we need to convert this into a raster data set so that we can sort of use this raster based analysis. So let's search for polygon to raster conversion. So click on polygon to raster, or maybe try the other one. Okay, so here I'm gonna select the zoning commercial buffer. I'm gonna convert this based on the commercial value field. I'm going to save this as commercial raster, and then cell assignment type is going to be cell center, priority is none, and cell size is 50. I'm going to click OK. So notice very carefully, the raster areas, the buffer areas have a value of 1, and the non-buffer areas have a value of 0. So that's already been created for you. So the raster would have the same values of 0 and 1 as well. So that's pretty important when you're using Boolean operators to actually perform analysis. So the next step would be to actually create a kernel density map of the OHCA point layer that has 150 foot cells and a search radius of 1500 feet. So how do you do that? Click on search, and here what you do is kernel density. So open that and use the OHCA as the input features, and the population field is going to be obviously yes, and then we'll save this as kernel dense OHCA heart attack layer, and then output cell size is going to be 150, and then the search radius is 1500. Okay, and then I'm going to change the value to feet. This is not square miles, that doesn't make any sense. This is feet we are talking about. So square feet, change the units, and then click OK. So once that analysis is run, let's examine the map. Let's turn off our commercial buffer zone. Okay, that looks okay. So go to properties, symbology, under classified, classify this based on standard deviation of 1/3, and then change the color to green to red. this way it becomes pretty easy for you to examine what areas are, if you want to choose a different color RAM, that's fine as well. So the map should look something like this. You have a bunch of red high density areas on the northeast corner of the map. So the next step is to reclassify this data, because this data has a bunch of values starting from 0 to 0.00031030119. So we need to classify them as reclassify. Using this tool will reclassify. Using this tool will reclassify the heart attack layer into two different classes. Okay, so the second class is going to be okay, the break value is going to be 0.0000 zeros and 4444. You can't really see that's because the precision is actually only 6 values, so we need to increase that to 9 values. Click OK. Now you got 00004444. So that's what we want. And now click on where you want to save this. H attack Q1. So I'm going to save it as that layer under a new name, reclassified data. So also the new values are going to be not 1 and 2 but 0 and 1. Don't trust the book. If you have the new book, they got it wrong. You need to change these to 0 and 1. And then I'm going to save. Click on OK. So you should see a layer like this, fairly simple, with bunch of brown dots. So if you actually set the layer color to, I don't know, properties, color is null, you should see a layer like this, a combination of heart attack and OHCA layer. So I'm going to turn off that layer. As you can see, these are actually overlaying. Some of these layers are overlaying on top of the commercial zones. So we need to find the intersection of those two. How do you do that? So we will query both the rasters with two criteria. So we're going to use a Boolean function, Boolean and spatial analyst. So what we're trying to do is, based on heart attack Q1 and heart attack, or actually commercial raster layers, just find me all the ones that are actually that have a value of 1. So whatever has a value of 1 and 1 becomes 1, and the rest of them becomes 0. So that's how it's going to work. So I'm going to save this as a heart attack Q2 layer and click OK. So see what happens here. So we're going to find, if I set this as no color and turn the rest of the layers off, and turn the commercial layer off and turn on the heart attack layer, you should see a layer like this. Pretty close to. So all the ones that are in blue, dark blue color, are the ones that are ideal for locating a heart defibrillator machines. So use that. So that's how you actually find an intersection of both. There are other ways to do it, but this is the way the book recommends you to do it. So you get sort of like familiar with the Boolean operators. So that's 11.5. So welcome to 11.6. Here we'll be using model builder to actually create a risk index for city of Pittsburgh. So the general assumption is that people who are poor have no health care, unhealthy diets and unhealthy habits, and they actually contribute to heart attacks. So in this tutorial what we'll do is we create an index for identifying poverty areas by combining 4 factors like population below poverty, income line, female-headed households with children, population 25 or older with less than high school education, and workforce males with 16 or older who are unemployed. So essentially there are 3 steps while actually creating this workflow. The first step is to calculate the z-scores for each of the 4 indicators. A z-score is usually calculated using the formula. So essentially you subtract the mean from each data point and then divide that by a standard deviation. So that's what we'll do for all 4 variables. And the second step is to create kernel density maps for all 4 input variables. Poverty, male unemployment, and less than high school education, and female-headed households. And then the third step is to we'll use a spatial analysis tool to add all the surfaces weighted by equal weightage, essentially by saying we'll give you a 25% weightage for all 4 rasters, and then you carry out all these steps using a model builder. So let's get to work. Let's open 11.6. So once you open that, you should see a map like this. The first step is to set your raster environment, raster analysis, cell size of 50, and we still continue using city of Pittsburgh as our mask. And then also make sure your geoprocessing options, all these options like overwrite outputs and and then add results to the geoprocessing operations to the display, all this is checked on. And now what we'll do is standardize input variables. How do you do that? Open the all county blocks layer, and as you can see here, female-headed household with children, this field needs to be sort of like standardized. So how do you standardize this? I'm going to right click and say actually right click on female-headed household, click on statistics. I'm going to use these statistics to actually calculate my standardized input values. I'm going to open Notepad and I'm going to paste my statistics. Okay, so this is for the female-headed household. So I'm going to close this. I'm going to add a field for the sort of like the calculated standardized value. Call it Z female-headed household CHLD. Okay, add a field like that with a float as a data type, and then you use this formula to calculate your field. Essentially that looks like, within parenthesis you put in your female-headed household with children minus a value of your mean. You need to subtract the mean from the value itself, each value, and then divide that by standard deviation. So standard deviation is 4. I'm gonna copy that and paste it here. So your formula should look something like this, and click. Okay, let's run that. So once that is run, essentially you have normalized your Z values. Okay, now that's done. So here's a twist. The reason why we are one of the reasons why we are using a raster based analysis is all this data is not available to you in one single file. So only female headed household is provided at a census block level, and the rest of the data is provided to you at a census block group level. So we need to calculate the rest of the values. So when the rest of the data has to be calculated, or the standardized variables are aware, we need to calculate that using this layer, which is the census block group layer. Unfortunately, it looks like the data is unavailable or something's wrong with the data itself. So let's try to fix that. Your data is under spatial analyst folder, under data. In the spatial analyst folder there is something called all county block groups. So this is what's being corrupted. For some reason looks like I'm going to export that data to a shape file. I'm going to export this to let's say within my exercise at chapter 11. I'm going to export this to chapter 11 GDB. I'm going to call this all county BLKGRPS. Click on, oh actually that's not the name. So let's add chapter 11 as a location, and then output feature class will be that, and then the expression is going to be the same. I'm not going to use any expressions here. I'm going to click on OK. I'm just going to export the data so that I know that this data is going to work for me. So I was able to export the data. I'm going to open the attribute table now. Okay, that's good. I'm able to see the data. So all I'm going to do is right click on the existing all county block groups, which is already symbolized, or actually you can right click on the all county block groups that you just added to the map, and then click on symbology, import the symbology from the all county block groups. So I'm just gonna import that symbology, right click on this and remove this layer and move this down there. Now let's see if we'll be able to open the data. Good. So we are able to get to the data so that we can standardize the values now. So the next step is to create a new toolbox and a model. So I'm going to go back to my catalog. Under my exercises, under chapter 11, I'm going to right click and say new toolbox, and the toolbox would be called index.tbx. call this index, and then I'm going to create a model. Within that, add a new tool called poverty index. Add tool to select the tools to add. Oh, actually, new model. So right click and say new model, and click on model properties, and then rename the model as poverty index, and then the label can have a space, but the title cannot have a space in it. The next step is to add a description or a style sheet. I'm just gonna ignore all that, click OK, and here what I'm going to do is calculate my kernel density. Add a kernel density tool. I hope you all remember from GS intro class how to actually create a model builder, drag and drop the tool into the model. And here I'm going to right click and click on open. The input points going to be all county blocks, and the population field is going to be the Z field for and we're going to export this to the chapter 11 GDB. We're going to call that kernel density for FHH CHLD, which is the female headed household with child, and click add. Oh, I'm going to export this as no, save, and then I'm going to go with the defaults and change the search radius to 3000, and here I'm going to click OK. So as you can see, now it has model parameters set and the output is also set. I'm going to right click and say right click on kernel density tool, and I'm going to say rename this as FHH CHLD female headed household kernel density. Click OK, and now right click on and click run. Right click on the model and click on run. So once that is run, as you can see, there is like a, and now add this output to the map itself. So I'm going to save my work, and then I'm going to choose for the symbology, I'm going to pick blues to reds, and I'm going to classify the data based on standard deviation of 1/4. Click apply. Your map should look something like this. So I'm going to turn off the dot layers so that I can see the data behind it. So that looks good. So the next step is to actually create a kernel density for the second input layer. So I'm going to right click and click on copy and paste the layer, but here the problem is actually there is no problem. Right click, open. The data source would be from the all county block groups, and the population field would be no high school. Actually the Z values for the no high schools and everything has been pre-calculated, so you don't need to worry about it. But we already learned how to create it, so it's no big deal. And then we're going to save this as KD kernel density no high school. Save this and click OK. So now let's see, I'm going to click on auto arrange. So the blocks, okay, so you can move anything anywhere. If you want to zoom out a little more, you can do that so that everything fits in one page. So now that's what I'm going to do is I'm going to go ahead and add the rest of the, I'm going to cut and paste some of this, paste, because I know that I need two more. I'm going to rename the first one as no high school, and the second one so just follow my steps here, just watch what I'm doing. Rename this as, actually let's open this, and the second value is going to be male unemployed, so I'm going to save this as KD male unemployed, save this, click OK, and I'm going to rename this as, take out the 3 at the end. I'm going to rename this as well. I'm going to open the last one. I'm going to change to Z poverty line, which is Z poverty. I'm going to change, save that, rename all this appropriately, and then rename the last one to poverty. So you can auto arrange this stuff if you like, scroll down, zoom out maybe. So whatever has been run so far would have a shadow underneath it. So I'm going to right click and add all these to displays, which is already done. So I'm going to go ahead and run the rest of the model. So now I'm running male unemployment. I'm going to run poverty, below poverty line index, and then I'm going to run no high school education. So all this is all. Once that's all run, what we need to do is average these kernel density maps to actually create our sort of like our index. So how do we do that? The tool that we need is kernel sort of like called weighted density. So point density, it's called weighted sum. Click on weighted space, click on that tool, on the weighted sum tool. It'll come up the input rasters. Actually, you know what, let's drag and drop it to the model, since we are using model builder to create this. And I'm going to use my connect tool to actually add them to the weighted sum model input rasters. I'm going to add all 4, and I'm going to open my weighted sum. So the weight here, I'm going to edit some of these values. So the total weight is for 100 or 1, so I'm going to change all this to 0.25. everything has an equal weight. So if you want to change the weight, if you want to assign poverty a higher weightage, you can change it here. Maybe reduce everything to 0.1 and give this a 0.7 a poverty. So it's up to you how you want to create this index, what assumptions you're going to make. So the assumption here is that it's going to have a equal weight. All the rasters will have equal weights. So what we're going to do is we're going to save this map as poverty index and click on save, click on apply, OK. So now I'm going to right click and say add to display, run this model. So once that's done, you'll have a raster. I'm going to minimize my model. I have a poverty index raster that's been created. So I'm going to right click and go to properties. I'm going to go to classified. I'm going to use a classification method of standard deviation classification method with 1/4 standard deviations. Click OK, and I'm going to change my ramp colors from, this is the fun part, I guess. So flip the colors. So as you can see, maybe you can turn off the rest of the rasters. The poverty index raster has been created based on the overlays of your 4 indicators, which is new high school poverty, male unemployment, and household, female headed households with children. So now that we have these, this is excellent. We need to create a poverty contour so that we output this as a vector file, not a raster file. So what we need to do is create zones or create outlines for these areas so that further analysis can be done, or maybe you can send this or share this with your clients or your colleagues. So I'm going to search for contour list, spaceland list. So, and then you can essentially again add this to the map, since we are using this model builder. Add this as the input raster, open, and then the contour value is going to be 0.0000, essentially 609. Add that, click on apply, click OK. So also give it a name, save it to your proper location, save it as poverty contour. So this area is sort of like an endangered area, sort of a thing, high risk area, which needs a lot of attention, obviously. So I'm going to right click, add to display, and run this last step. So once that is run, a contour will be added to the map, which will have an outline, a green color outline. So what we need to do is change that to a thick black outline, and that, and now you have identified the really high risk areas that have a higher rate for heart attacks, and you can probably come up with policies and work with local aldermen or whatever to actually counter some of the effects of this high poverty areas, maybe come up with programs. So that's 11.6, and that concludes our tutorial walkthrough, and good luck with your assignments.